In this video, we're going to focus on power calculation and the components of AC power. And our focus is in calculating power and creating a power equation that allows us to understand what the characteristic of the powers are. So let's say if we have the box that is made out of capacitors and resistors and inductors and any other component, and we are putting a current into it, that is I, and we've got a voltage there, and let's say the current is a general form of current, sinusoidal current, which is Im cosine of omega t plus theta I, and the voltage has also a general form of Vm cosine omega t plus theta v. Great. So the power, instantaneous power in a moment in time, so the instant power can be calculated by simply taking the v of t and multiplying it by I of t, which basically ends up being Vm Im cosine of omega t plus theta v times cosine of omega t plus theta I. Perfect. So we can leave it at there. At this point, we can find the instantaneous power value at any given point of time by just plugging values in there. That's great. But we want to reorganize it so we can kind of have more of a refined conversation about its components and make some decisions based on that. So even though I'm not going to go through it, it's basically applying a number of trigonometry identities to this one, and then we'll be able to write P of t as Im Vm divided by 2 cosine of theta v minus theta I, and then continue on to write the rest of this, which is going to be Im Vm divided by 2 cosine of theta v minus theta I times sine of, cosine, let's back this up, cosine of 2 omega t minus Im Vm divided by 2 here it would be a sine of theta v minus theta I multiplied by sine of 2 omega t. So now you might ask, why did we write this? If you look at this equation, you will see that the only part of this equation that is a constant is the very first term. So literally this is a constant value, which means if I were to take a power average of the instantaneous power, these cosine values or these sine values will zero out when you go over a period. The only thing you're left with is the average power. And the average is this quantity, and therefore that's why it's called an average power. It's represented with capital P, and the units are watts. This is really the wanted power. That's the power that does a lot of work for us. And if you notice here, that's the same, so that's P times that thing. One thing that's new is over here, and this is the power that is stored and given back, so it doesn't do any work. So if you're buying power, your goal is to eliminate that. If you're selling power, your goal is to eliminate that, but it really has to do with what's in this box, and we'll talk about it some more. So, but this quantity, its name is called reactive power. And reactive power is represented by Q, and the units are written as V to separate from watts. It has its own unique identity. Is referred to as volt amp reactive, the unit. All right, so that's the instantaneous power, and we have the components. A lot of time what you will find, this is really written as P of t, instantaneous power, is equal to real power plus real power times cosine of 2 omega t plus minus q sine of 2 omega t. One thing you notice that the power is changing at twice the frequency of your original signal. That's worth noticing. Okay, and so our goal in the long term is to basically maximize P and minimize Q. But let's kind of play a little, not play, but experiment with something. So remember, this was created by assuming that I is going to this box, and then you have a V across the box. Now let's take a scenario. What if R is the only thing in the box? If R is the only thing in the box, you will find that theta V and theta I is going to be exactly the same, because remember, Z, if you go to a phasor domain, Z is equal to V over I, and for an R, Z is equal to simply R, which the angle is 0. And if you notice, theta V minus theta I would be basically the phase of Z. So if you got an R, this is equal to 0, which basically tells us that cosine of this value is equal to 1, which means all your power is going to be real power. So real power is going to be Vm Im divided by 2 times cosine of 0, which is 1, and then the Q will be equal to 0. Now let's kind of play with this and say, let's say if the only thing you had in here was inductor, if you only have inductors in here, that means Z is equal to J omega L, which basically says it's going to be omega L with an angle of pi over 2. If that's the case, then what that tells us is that the theta V minus, remember the Z is theta V minus theta I is equal to pi over 2, which basically cosine of pi over 2 is 0. So now your real power is 0 and your reactive power is everything. Of course, fortunately, and then if you do the C or the capacitor, you'll just be pretty much the same, except your Q would be minus, because it's minus 90 degrees. Now, most things will be somewhere in between that. This is a very important concept, because this will tell us is the most efficient thing we want to do, and this is the place typically we don't want to be, because none of the power that you are in this getting to the system can be used to perform useful function. Everything is stored and then returned. Okay, so what they've done is they've come up with this the name theta V minus theta I is referred to as the power angle, power factor angle. What really most people use is cosine of this value, theta V minus theta I, is referred to as power factor. And power factor is commonly used. Power factor is usually between 0 and 1. 1 would be basically you have 100% real power, and 0 is 100% reactive power. So of course you want to be as close to 1 as you possibly can. Typically when somebody gives you a power factor, they also tell you the power factor. Let's say they say power factor is 0.5. They also will tell you that is it leading or lagging. And what they're basically telling you, if it's leading, they're saying theta I is leading theta V. Now, if you want to think about it, theta I is smaller than smaller than theta V, which basically tells us that when you do a cosine inverse of 0.5 to find theta V minus theta I, you got to make sure you add a minus in front of this. Okay, because theta V minus theta I have to be less than 0 if it's leading. Okay, in the lagging case, you don't have to do is plus cosine of inverse cosine of 0.5, which means theta V minus theta I is larger than 0, where this was less than 0. So the bottom line is, if you're the one defining power factor, then you have to tell whether your 0.5 is leading or lagging, and the leading comes from the fact that theta I is leading theta V, or in other words, theta V minus theta I is less than 0, and lagging comes from the fact that theta V minus theta I is larger than 0. That brings us to the end of introducing instantaneous power, real power, and reactive power, and power factor of the kind of main thing we covered in this video.